right, so just kind of going back over what we talked about a little bit of the other day. We had more arc lengths and area of sectors that we're talking about today. We talked about a little bit of that back. Anyways, here's your formulas, the arc length, and here's your sector area. We've got 120 here, so we're going to put it over 360, and then we've got our radius put in there. Okay, if we simplify 120 over 360, we get what? Yeah, it's 1/3, because there's 320s that will go into 360, so it's 1/3 of that. Times, we got 20 pi over 1, then just multiply those straight together, and then you have 20 pi over 3. 20 pi over 3, or you could put 20 over 3 pi beside it. All right, any questions for arc length? So that would be the arc length and radiance with your radius. Okay, and then your sector area, which is that piece that's shaded, again, you have 1/3, right? Because it's going to be the same thing, 120 over 360, which is 1/3. And then your radius squared times pi. And that's going to be 100 over 3. So 100 over 3 pi. So you can write pi beside it, or you can put it with the top. Either way is correct. Now that would be a decimal repeating, so I'm just going to leave it in fraction form. Both of them are simplified. This would be units, and this would be units squared. I'm just going to put u squared for our area. Okay, do the same thing. I'm going to put AL for arc length. Now for this one, it doesn't have the degree. It says find the length of the arc indicated the area. Oh, it does have the degree right there, 90 degrees. Just kidding. All right, so we've got arc length because the central angle is the exact same thing as this arc, right? They're equal. So we've got 90 over 360, just using this formula above here, times 2 pi r, and my radius is 12. Just put that over 1. So if I simplify 90 over 360, we get what? 1/4 times 24 pi over 1. That would be 24 over 4 pi. And 24 divided by 4 is what, Connor? Okay, so we have 6 pi. And then you can put a u behind it for units. And then the sector area is going to be the same fraction here because you're going to have 90 over 360, right? So I can just put 1/4 over here times. And then you got pi r squared for this one using this formula up here. Pi r squared. My radius is 12. All right, so now we've got the radius in here. So the radius squared, that's 12 squared, which is 144. And then you're going to multiply straight across 1 times 144, which is 44 pi. You can put it on top or beside. Don't ever put it on bottom. Okay, so either on top or beside it. Okay, and then 4 times 1 is 4. All right, and that's my sector area, but I can simplify that, right? 2 will go into both of those. 4 might be able to go into it. Okay, so 144 divided by 4, y'all got 36. Okay, good. All right, so then you have 36 pi units squared. All right, so here is difference. We're looking for the shaded part. Can anybody tell me how they think that they would find the shaded part? All right, Jackson.
Subtract the entire, not the entire shaded part, but subtract the entire top semicircle from the triangle.
All right, so if we had a full circle and we divided by 2, we're going to get a half a circle, but not all of this half circle is shaded, correct? You're going to have to subtract the area of a what out? The area of a triangle. Now, the area of a triangle minus base times height divided by 2, that's the area formula for a triangle. Yes, the radius is 10. We can do that. Okay, so I've got full numbers over here. I do not have the base or the height of the triangle. I need the base and the height here. I need both of those. Base and height have to be connected to what? A right angle. You'll always see a right angle where your base and your height are connected to. This is not a base or a height. No matter what type of figure you have, if you're looking for base and height, it has to be connected to a right angle. Y'all have heard me say that before, right? Okay, base and height, or you could use this as your base or height. Doesn't matter, as long as both of them are connected to this. This is neither. All right, so what do you think they want you to use? 90. So 30, 60, 90. So opposite of my 30 is x. Opposite of 60 is x square root of 3. Make sure you're writing that down. And then the opposite of your right angle is 2x. So Hayden, what's x? Base and height are connected to that right angle. So 10 and 10 square root of 3. So 10 and 10 square root of 3 is what I'm going to put in for base and height. And you can put in base for 10 square root of 3, or it doesn't matter. You can put in either one because you're just going to multiply them. So what is 10 times 10 square root of 3? Okay, so 100 square root of 3. So I'm just going to write that. 100 square root of 3. Can I do that? Is that okay? All right, save room. We don't have much room here. All right, so then this, 100, 10 squared is 100, right? I'm just going to write that here. Divided by 2 is 50, right? So I got 50 pi for that one. Y'all agree? All right, then I've got 100 square root of 3 divided by 2. What is 100 square root of 3 divided by 2? Okay, so minus 50 square root of 3. Can I actually subtract those? No, this is like x and x squared together. I have to have the same thing behind them. So this is my answer. And does the triangle have to be the one in the back behind the minus? Yes. Because you're subtracting it from the half circle. This is your half circle. So your area is 50 pi minus 50 square root of 3 units squared. So we're talking about area. That is your answer. Turn to the back. Okay, so then we're going to be looking at, we're still looking at area. So we know we're going to deal with this sector area. Okay, so sector, I'll write it all out. Sector area is equal to x over 360 times pi r squared. That's a formula, and I just put that over 1. That's the formula that you're using for your sector area. Okay, do I know what x is going to be? Yes. That's the degree of your arc. Okay, so SA, which is sector area, is equal to 60 over 360 times pi, my radius is 12, squared. Now I'm going to go ahead and put it over 1. Okay, so 60 over 360, what does that simplify to? Yep. And 12 squared is 144 pi over 1. That's 144 pi over 6. Does that divide evenly? Okay, so it works out. Okay, so we got 24 pi. Now, that's not my answer, right? That's if my circle, and you just have to understand, is if that full piece of the circle was all shaded in. Y'all agree it's not, though. Okay, so this is the area sector, is if everything was shaded in. Okay, what shape do I need to subtract from that? What shape is it? A triangle. All right, so what measurement is this? 12. Okay, and so that's going to be, and then what degree is this? 60. if these two sides right here are equals, making these two angles equal to each other, how many degrees do you have in a triangle? Or what degree do you think you're going to put here and here? Yeah, because there's 180 degrees in a triangle. My central angle is equal to the arc, as you guys know. 12, this is my radius and this is my radius. The opposite angles will be equal to each other. That's how I figured all that out. So you have to kind of think about it. Which, this is fun. Because you know your base and your height have to be connected to a right angle, right? So you have to make it. You have to make that straight line. This is going to be my height of the triangle. All right, so then I've got, well, there's two different ways I could do that, but here's my right triangle. Who thinks that they know what I would do from here? I could use what? I could use Pythagorean theorem, but I could also use 30, 60, 90. Which one would y'all prefer? Raise your hand if you want Pythagorean theorem. Raise your hand if you want 30, 60, 90. Now, I will show you that 30, 60, 90 is going to be a little bit easier, so I'm going to show you that. Okay, let's make it easier on ourselves. Okay, half of 60 is going to be what? Half of 60 is 30, right? Okay, so opposite of 30 is your x. See how this is going to be easy for us? Because x, if you half 12, because if these angles are all equal to each other, these sides are all equal to each other, if you half 12 right here, you get what? So your x is 6, which is going to make the height right here, opposite of 60, x square root of 3 is going to be 6 square root of 3. See how much easier that would have been? What's my base? 12. Okay, so let's look at that. Base times height divided by 2. We'll do it over here. That's the area of a triangle. I've got my base, which is 12, because it's an equilateral. All sides are equal to each other. My height, y'all told me that x was 6, right? And so that's going to be 6 square root of 3. And so what is my area of the triangle going to be? What's 12 times 6 divided by 2?
36. 33.
Yeah, so that's going to be minus 36 square root of 3. And so that's going to subtract the area, just going to give me this shaded part. If I subtract it, if everything was supposed to be shaded, but I take that triangle out, that's only giving me the area here. So the area of the sector minus the area of the triangle will just give me that shaded part. And so that's going to be units squared behind it. Okay, now that's, all right, what do y'all think we're going to do here? All right. Okay, so there's two different ways actually you can do this, but we're going to do it the easier way, I think. Let's find the area of this sector here and then add this triangle back to it, since it's all shaded right here. Now, if you did it a different way, you can tell me, but if we add this sector, so the area sector, what's this degree on the outside going to be? Okay, so we got 300 over 360 times pi r squared, and my radius is going to be what? If my diameter is 12, yeah, my radius is going to be 6. Y'all see what I'm doing? I'm going to be finding the area of this piece right here. Just this piece. We're going to add the circle back in, or the triangle, sorry, the triangle back into that piece. Okay, so just the area of this piece right here, right now. All right, so I'm going to go ahead and cancel out this 2 zeros so I can go ahead and, what is that simplified? 30 over 36. You said 5, what? 5 over 6. So 6 goes into both of them. That's correct. 5 over 6. 5 will go into 30. I'm sorry. 6 will go into 35 times, and 6 will go into 36 6 times. Times 36 pi over 1. So that's going to be what? Okay, so 180 pi over 6, which is what? You got 30. So 30 pi. Now that's this piece. And because this is shaded, we're not subtracting anything out. We're going to add it. So we're going to be adding the area of this triangle. So I'm going to put the area of the triangle over here, and then we'll add it, whatever number we get here. All right, so we need a base and a height connected to a right angle. So a base and a height connected to a right angle. All right, if this is 60 and these are my radius, that means I'm going to have an equilateral triangle, so 60. I'll let you guys try to figure that out. Use your 30, 60, 90. And I'm going to help. And there you go. I forgot to hit resume. Okay. There's the area of your triangle. Figuring it out from 30, 60, 90 triangle. X was 3. And we solved that the area of the triangle was 9 square root of 3.